dive in. So I'd like to first start by introducing our moderator, Haisa Antunes, who will be moderating the Beyond the Bus, How Can AI Create Value in Batteries? Haisa, the stage is yours.
Thank you, Michael. Hi, everyone. It's great to see you all here today. My name is Haisa. I'm a project director at the Battery Forum and a cell engineer at Tesla. I'm excited for us to explore how AI can create value in the battery industry. Today we have an exceptional group of panelists joining us. They bring deep expertise across AI, R&D, manufacturing, and performance management sectors. And I would like to introduce Michael Pacelli from Monolith, Praveen Tayal from Honeywell, Matthias Kuipers from ACCURE, and Casey McNamara from Capgemini. So before we dive in, I'd like for each of you to quickly introduce yourselves and share about what you and your company are working on. We can start with Michael.
Hi, everyone. My name is Michele. I'm VP Product at Monolith. We make battery developer and manufacturer faster and clever by using AI. We develop artificial intelligence algorithm that help you to develop it faster and more intelligently.
So, Praveen.
Yep. Hi, everyone. My name is Praveen Tayal. I'm based out of India. I'm working as a principal data scientist with Honeywell Connected Enterprise. It's our AI and software innovation group. And we have a brand called Honeywell Forge, which is an IoT platform for industrial buildings and cybersecurity. I'm kind of passionate about developing the AI strategy for our new products introduction, as well as working with our customers as an analytics consultant. I'm really excited to be here and look forward for our discussions.
Thank you, Praveen. Matthias, can you introduce yourself?
Absolutely. Yeah, hello, everybody. Good morning, good afternoon, wherever you are located. My name is Matthias Kuipers. I'm head of research and development at ACCURE. We are a company located in Aachen, Germany, with roughly 70 employees. We are one of the, let's say, rather large startup companies in Germany. And we run battery analytics on operational battery data. So we get operational battery data from the field where the battery is operated, and we process it using cloud computing. We use some AI methods. We also use some battery expertise-based methods, and we characterize batteries according to lifetime, safety, and performance. That's kind of our thing. Yeah, looking forward to the discussion.
Nice. Casey?
Hi, everyone. Great to meet everyone. Casey McNamara, based out of Chicago. I lead a team within Capgemini, a consulting firm that we call Data-Driven Transformation. So we do a lot of work. My team does a lot of work within the manufacturing sector, within our intelligent industry practice, and in particular in batteries. And so we've been deeply involved in the battery sector, from helping launch some greenfield gigafactory initiatives, as well as deploying AI in brownfield and looking at things like, how do we help with predictive quality? How do we help with various process optimization type initiatives? So happy to be here, excited to be here, and excited to dive into today's conversation.
Awesome. Thank you for the introductions. Let's learn a little bit about AI to start. Casey, can you explain to us, for those less familiar, right, how AI works, and can you also highlight the main models that are commonly used out there in the industry?
For sure. Yeah. So AI is about, at core, machines performing tasks that typically require human intelligence. So typically we're looking at things like finding complex patterns, or machines helping make decisions. So breaking down AI. So first we have machine learning, which is focusing on algorithms that learn directly from data. A classic example is random forests, which often will be used to predict outcomes, for example, with some capacity fade models. These will work from features like our time series data and other sensor readings. When we break this down, we also have the world of deep learning, which goes further and uses layered neural networks to handle usually much larger data sets, and from this automatically extract patterns. And so within this, there's a world of reinforcement learning, which is typically learning through trial and error, which could be useful in things like optimizing battery formation protocols. And also within deep learning is the whole world of Gen AI and large language models, which are built on transformer architectures. And large language models are specializing in machine language tasks. It doesn't necessarily have to be our language, but language tasks. And so are good for things like summarizing technical literature, different maintenance and lab reports, et cetera. With it, we also see in this world this idea of hybrid models, which are combining first principles physics-based models, like our electrochemical principles, with AI and machine learning. And often here, there's kind of sometimes now we're seeing a blending of digital twins into the AI space for real-time monitoring and anomaly detection. And so, I mean, all of these approaches have kind of different reasons to use them. And sometimes I think we think of AI a bit like a black box. A big world right now is the whole world of explainable AI. And how can we dive deeper to get more transparency into why a model is making decisions and what do those decisions mean? And so I think this is very important for this industry, where we need transparency, and we need to have that right level of trust and traceability. So kind of applying all of these things, I think it's good to think of this as kind of AI as a toolkit, with the real priority for most companies right now thinking about what's that solid AI scaffolding that you need to build so that you can quickly deploy the right models and tools effectively depending on your use cases.
That's very clear explanation. Thank you. Yeah, I'd like to follow up with all the panelists now, so we can learn how they are using AI, right? Among the AI models that Casey just mentioned, which ones have you applied? Can you share some specific use cases that demonstrate their impact in your sector? We can start with Praveen.
Yeah, so I think Casey pretty much covered, the majority of the spectrum of the AI models, and there are physics-based models, like he mentioned, and machine learning models, and the concept of a hybrid model. What we have noticed in practice, that the hybrid models are typically important for predicting the remaining useful life, because there is a lot of domain expertise which we require along with the data-driven machine learning. Typically, supervised model like regression classification, or unsupervised like anomaly detection, are quite prevalent in the context of manufacturing. Because especially anomaly detection offers the biggest opportunity to augment the operator and process engineers to capture the defects early on as possible. And there is other class of models that very prevalent is in manufacturing, is like when we have to really track the key performance indicators. So those indicators are like, we have to establish some sort of a relationship between the process variables versus the outcome. So whenever there's a deviation happens in those indicators, it impacts the quality and the throughput and so on. So in the battery context, like during the mixing process, or part per million in the cell assembly. So those are kind of key performance indicators. So there, I think if we can quickly detect the issues and identify the root cause and take actions, that will actually improve the entire manufacturing process. But the challenge there is that so many process variables and the complex dependency among them, it could be really time consuming and a challenging task. So I think that's where I think these platforms help. For example, as a Honeywell, we offer like a production intelligence guided diagnostic. So that kind of uses all the diversified machine learning algorithm, basically takes the goodness of multiple algorithms and then applies some causal inferencing techniques, which we feel are actually quite important for the root cause analysis, because most of the machining algorithms are actually correlation. Of course, those are a pretty important. Correlation is like the first step in order to address any causal relationship. But I think a blend of the causal influencing techniques can actually help detect, those issues and the root causes in a better fashion.
Thank you. Good explanation on the manufacturing sector. We can move with Matthias, and then from there, you can also jump in, Mikhail and Casey.
Okay. Yeah, like I said at the beginning, we run our battery analytics on operational data. Just to draw you kind of a picture, we have currently 6 gigawatt hours of battery storage or batteries in general in our monitoring each day. So we collect millions of data points of current voltage temperature every second, minute, whatever. And yeah, you can only get a hold of these gigantic amounts of data if you use like some smart processing. And AI, of course, is one of the relatively powerful methods to crunch data sets that are just enormous. So we have different kinds of applications for AI. If possible, we try to use what's called supervised learning. So that's basically when you have a training set, so you already know the inputs and you know the outputs, at least for a dedicated set of data. And then you basically throw in, or you train the AI to learn the correlations. This is really helpful for things like battery degradation, for example. We know that temperature has an impact on battery lifetime, but what's the impact, Like how do you put it into equations? And AI can help there a lot if you have supervised learning methods. And then there are, of course, those unsupervised learning methods where you don't really have the output, but you can still use AI, for example, for clustering. We use that a lot to detect which batteries behave similarly, basically to group batteries, like which ones are the ones that are aging faster, which ones are the ones that are aging slower, just separating the batteries according to age or the way they are operated. There are many different applications. And then there's, of course, anomaly detection. This one is a big one because things like safety, for example, is always related to some sort of anomaly. So it's really powerful to use anomaly detection by some sort of AI to find those batteries that are just those, the 1 in 100,000, which you usually wouldn't find with your bare eyes. But if you can find those outliers if you run the anomaly detection. And I also want to briefly mention hybrid models. This is a big one for us because we proud ourselves to be a company that is based on a lot of battery experts. Like we want to give as much of our battery expertise into solving the problems before we run the AI. And therefore, we really enjoy using those hybrid models where you apply a lot of domain expertise. And then the remaining issues that you can solve with your knowledge, you solve with AI. And that has been the most powerful approach in our eyes.
Okay, I'll go next. So largely, a lot of our applications have already been mentioned. Anomaly detection, that is something that we do using autoencoder. We don't do so much on field data, more on aging tests, long aging tests, and helping experts going through gigabytes and gigabytes of data that gets generated every day. We have started using hybrid model. Really interesting. It allows you to use less sophisticated and simpler and nimbler physical model because the kind of AI can can kind of do the rest and pick up the delta, particularly in condition. Active learning is something that we do on the early stage battery development. So, for example, we help battery developers select what are the best tests to run. You can imagine that if you have, lots of combination of material, a different quantity of material, different manufacturing ways to manufacture a battery, it can easily go in the thousands of combination. You can't possibly test all of them. Using active learning is actually a good way to understand what are the most informative tests that allow you to learn, particularly if you have a specific objective in mind. And this is something that we've been very, very successful doing, and really streaming down and slim down the number of tests, which are usually the time-consuming part of the development, and using active learning to learn more and more as you do more and more tests. So these are just some example of how I've been using AI.
And within Capgemini as well, so we have an AI factory methodology that we've been deploying to different industries, and we've been doing this with a number of clients within the gigafactory space. So we have a gigafactory specific kind of AI factory model, which helps us deploy AI use cases quickly. Sometimes doing POCs just within a few weeks, leveraging reusable model templates with other things that help us quickly pull in the right data pipelines and bring in the right validation framework that's already pre-aligned to battery manufacturing workflows. And this allows us to quickly test and scale a lot of different use cases. We've done things like to some of the specific models we talked about, using deep neural networks for forecasting, in particular capacity fade, and other things like getting into AI-guided slurry formulation tuning using Bayesian optimization frameworks. So a lot of great opportunities. I think the key though is to move fast right now. I think that's the AI right now. That what's different in today versus 5 years ago, 10 years ago, is speed, right? Really, and so we want to be able to make the most leverage of that speed and be able to prove these things out as quickly as possible, so that we can get the right buy-in, prove the value, and then move to scaling that to get the value.
Thank you. That's fascinating. We just heard some great examples of AI adding value. But does anyone here have any different perspective also to add, maybe a challenge or a limitation that you'd like to highlight? It'll be great to hear about any roadblocks that we should be looking ahead to move forward with AI. Let's start with Matthias this time.
Sure. Yeah, my prime example for these kind of questions is always safety. Safety batteries are very safe, first and foremost. Usually, if something goes wrong, it's like 1 in a million, 1 in 100,000. Nevertheless, if you have 100 million cells in operation, something will go wrong, of course. Now, how do you detect these 1 in a million events? It's super difficult because safety criticality can manifest itself in like a million different ways. But you can use AI in a smart way to do this anomaly detection, like I mentioned earlier. But now, how do you validate it? And how do you train your model? I mentioned that we mainly use unsupervised learning because we don't really have a lot of data that we can train on, at least at the beginning. Now we have, but at the beginning, we don't really have a lot of data. We have unlabeled data, basically. And then it's really powerful if you can run some sort of test or validation. But who in their right mind would take a battery that has been flagged as possibly safety critical and keeps operating it, even if it's done in a lab environment? It's still costly and it can still be dangerous. That's why it can be very challenging to validate some of the results and to acquire labeled data, like to acquire scenarios where okay, this has absolutely been a safety critical battery. And that's one of the main challenges that we are facing. And the only way we can come around it right now is by acquiring even more data. Like we are collecting data even across domains. So we have one customer operating a storage system in the US, and we are collecting those data and try to find the correlation that have few labels that we can use. And then we use that information to run it on a different customer's data set as well. That's the only way, but because the lack of those labels is just very challenging.
Thank you. Can move with the next person, Kel.
Yeah, so I'd say one of the most surprising thing that our customer finds surprising is that AI doesn't always extrapolate very well. And people have all this sort of expectation of AI being this magical thing that extrapolate and can predict pretty much anything. And I kind of often kind of play back to them in kind of simpler terms and say, hey, you're kind of teaching English to a model, and then all of a sudden you're interviewing that in Swedish or German or Chinese. That model is not going to answer because that model has been trained in English, not in Chinese, not in Swedish. And there's a very simple parallel where kind of people expect that if we train a model on a battery charging it at 1C at ambient temperature in the UK, they can take that model and apply it on a battery of a completely different chemistry, fast charging at 3C in the middle of Sahara Desert, and they expect that model to kind of yield the same performance. That is often not true, and people find it very, very surprising. And I think this is a little bit of a children of the expectation of the ChatGPT having this kind of magical aura of AI being magic. AI is not magic, unfortunately. We haven't invented magic, and so there's a very kind of intentional and rigorous way to kind of train model. And so yes, that's one of the biggest challenge in going into customers and organizations that are not used to work with AI. This is one of the barrier and one of the biggest education that we have to do with our client. So yes, AI doesn't fully extrapolate as much as you think.
Awesome. Praveen, do you have any comments?
Yeah, no, I like what Mikhail has mentioned. Yeah, I mean that's not true at all. It's not magical. In fact, I've had situation where the same equipment, make and model, put in a different context, and its behavior is totally different. So not even the AI can extrapolate, cannot extrapolate, but also it's not transferable so easily. If you think that you have built AI for a particular model, and if I use that to a different context, it's going to work. It's generally not easy for it to work very well. Apart from that, I think what I would like to highlight that even the type of data that we use to build AI can be the AI building AI algorithms or building AI solutions could be challenging. Simple things like when we mix the data types. For example, if we have an anomaly detection model and we have a mixed data type, for example, binary or discrete data, transactional data, plus the continuous data, it's not easy. So continuous data, I mean like a streaming, like a temperature values that are streaming over a period of time. And binary or discrete data, I mean like something like on and off conditions, commands, open and close conditions, and so on. So it's definitely not easy, because if you think of a neural network or any other anomaly detection tools, the underlying logic is like a gradient calculations and backpropagation. That's the typical algorithms that they use. And for the discrete variable, it's, we cannot get those gradients so easily. So we have to do a lot of transformations and so on. So even I think we have to look at the data itself. And based on that, I think we have to really figure out, which algorithm or which methodology is actually more suited for the solution.
And that actually sets the stage for what I wanted to talk about here on that one is, so I think we're not too far off from a future. One thing we haven't really talked about is this idea of AI agents, and it's a bit of a buzzword, but also a big theme right now. And we're not too far off from a future where the biggest user of every company's data isn't going to be a human sitting at a desk, but actually an AI agent that's consuming that data to do things, right? And that AI agent reads data differently. It doesn't think about data in the same way we do. And a big challenge, I think, in the world right now is preparing for that world. And we're seeing organizations start to really take this seriously and accelerate this AI readiness effort, which means investing and thinking about things very differently. One is the architecture, right? New streaming architectures, so that the data is not necessarily just living in silos or extracts, but it's available on demand for those agents. Things like Edge AI are finally coming to life in a big way. I think there was a lot of talk about Edge in the past 10 years, but haven't seen it grow as fast as it is right now. And then advanced labeling techniques. And I know a number of panelists here have talked about labeling, but it's a serious thing because no longer we're moving away from this old data management world where it was just about getting the data accurate from your transactional systems. Now we need to get that data accurate. So there's a new resurgence on just classical master data management focus, but also we need to think about, is that data ready for that agent or machine to read? So now we're seeing also a resurgence with things like knowledge graphs and other semantic layers, which are developing in parallel to AI efforts so that we can make sure that we have the right AI scaffolding in place for this so you're ready for all of the potential valuable use cases in the future.
Thank you. Some of you already answered my next question in terms of how you're handling those challenges, right? Matthias mentioned that in terms of safety, you'd need to collect more data, have a larger amount of data to be able to train your safety models. Mikhail, in terms of educating your customer, right, in terms of explaining that AI is not magic, and Praveen in the same way. Casey mentioned in terms of the data quality also. One question that I would have for any of you that would like to jump in is, what key changes that you think, whether in technology, mindset, or in our infrastructure today, do you think need to happen to fully unlock AI's benefits? Anything you'd like to add?
I'm going to start. I could start just to follow up on, continue that thread. So, similar to what I was kind of getting in with being ready for AI, I think another thing to think about here is new types of data for these use cases, right? And I think this is one of the biggest challenges and also one of the biggest opportunities, in that your real data is no longer just living in your transactional systems or your historians. In fact, a lot of your organizational knowledge, only about 25% of it is even written down or stored in any system. The rest is living kind of scattered either in people's brains or in different emails and meeting notes. So I think the future really is about blending all of this unstructured knowledge with structured data, so that with maybe some techniques to help with this, with automatic cross-labeling, so that AI can correlate insights across the board. So think of this as almost like building a true organizational or digital brain that for now, the majority of organizations do not have at all. They might have individual nerves aligned to individual systems for use cases, but they don't have that fundamental brain, and that's the task at hand. And so we're seeing this. I think there's a lot of initiatives going on right now which are kind of tied to this and can help with this. So, for example, our Argonne's battery data genome I think is something that can really help accelerate this type of end-to-end interconnectedness with data, and also start to bridge that gap between the unstructured and the structured world. And I see this not going to be an overnight type thing, but something that is going to be a journey that's starting. It's already started, but it's going to continue to accelerate from here onward.
Thank you. We are 9 minutes away from the end of our panel, so I'd like to jump in to our last question, and we can take our time to discuss about that. I'd like to talk a little bit more about the future. Given how quickly AI has evolved since ChatGPT launched in 2022, let's fast forward to 2035, 10 years from now. So imagine there's a headline about AI and batteries, right, in your company. What would it say? What's the innovation that would make people look back and think, we should have seen this coming? What's your opinion on that? You can start with Mikhail.
Yeah, so we have been toying with this concept of high throughput lab, where basically AI does most of the lifting, design of experimenting, and everything gets kind of done either by robot or by expert but highly informed by AI. This is where we think is the future. Is like, at some point a lot of the lab will be informed and supported by artificial intelligence. And so I think this is probably what we expect in 2035, having few of these high throughput lab powered by us.
High throughput, awesome.
Yeah, I would say from our perspective as a supplier of inspection equipment, if you look 10 years out, and then you'd say, well, boy, they did a great job of embedding some type of adjustable AI into their inspection equipment. So the equipment that some of you are using properly detects defects in batteries without a lot of false positives. In other words, it's not rejecting things that should not be rejected. And we have some inspection equipment already that does that. Those are sophisticated X-ray systems, but it has very rudimentary AI in it. So long way to go, but 10 years from now, they're going to look back and say, boy, those guys at Zeiss, they really got it together and they really did it.
Yeah, let's talk, David.
Thanks for the comment, David. Praveen, are you going to jump in?
Yeah, I think AI is going to get more autonomous going forward. So let's say the AI models may not be just limited to the batteries themselves, but also look at more holistically, like what is the physical equipment of manufacturing that is used, and what is the surrounding infrastructure. So it's like it can actually go to multiple layers and can predict, even the machine breakdowns, and schedule the maintenance before the event happens, right? So that like everything runs smoothly and proactively. So I mean, not sure we can predict everything, the future of AI, but I feel that, we feel that autonomous systems will actually take on. And in terms of the compute, and I think we think that, the quantum computing can also be in the mainstream, because if you run like design of experiments or simulation, I think this technology can actually really help improve the quality, productivity, and reduce the time in the design and the manufacturing.
And so in many ways, I think if we're thinking, 2035 seems way out, but it's actually not that long. But in the world of AI, it is far. But I think a lot of stuff is probably right in front of us right now if we dig deep enough. If we start thinking beyond just the battery industry and the need, back to that idea of machines that are looking for patterns and trying to make sense of complex data. By 2035, we'd probably look back and say, oh, well, of course it would have changed things because we already saw this happening in different industries and the clues were already in plain sight. So, I mean, one example, I was reading an MRI paper around breakthrough scans where, doctors don't always have the right amount of data to get clear images. And this is a popular application for AI right now. And we just talked about the X-ray scanning and whatnot. And I mean, this is a great example where that exact kind of method can be also applied to gigafactory factory floors where AI models can be used to help kind of see imperfections within battery electrodes. And so I think a lot of this is probably right in front of us, and it just hasn't fully manifested itself. A couple other examples, I think. Right now, across the world, we're seeing a big transformation in how software gets developed. And this is going to change the way that we deploy operational technology as well. I think, and we're already starting to see some shift away from an industry that's historically run on rigid monolithic processes and systems to something that's more AI enabled through AI enabled coding that's going to help accelerate the release cycles within some of these, moving away from some of these monolithic approaches to something that's much more modular, which is going to change, I think, just the way that we can manage and build systems and software that support our processes. The other side, I think, is the workforce shift. A lot of times people are talking about, oh, well, we don't have these skills that, we have to hire 1,000 new people and we don't have that. But, I think the world is changing into one that we have more scalability and who can support these tools. 2 years ago, I think it was really rare on a plant floor to see anyone writing Python scripts. Now I sometimes tour a plant floor and I'll see 50 different computer workstations and there's nothing but Python IDEs set up, and this is in a gigafactory, right? And that's it seems a little weird, but also it starts to make sense when you think about where the world's changing. So I think this is going to actually happen pretty fast and probably even before 2035.
Thank you so much for highlighting what the transformations that we're already seeing today. Yeah. We can move with Matthias' opinion, and after that, we can go ahead with some Q&A questions.
So I was actually going to mention something very similar to Casey. I think what's going to change is the mindset. Not so much the technology, at least that's my stomach feeling. The technology is already available and it's quite okay, infrastructure is available. But the mindset, there are people who have a lot of data who just do not know that it's super valuable information in there somewhere. And they just don't know because they are just not in the field of AI or in battery analytics or any sort of analytics. So they don't know how much value is actually in the data that's just lying around. So I think that's going to change a lot. People will identify that, oh, my data is actually extremely valuable if I make use of it. So that's going to change. On the other hand, I mean, maybe it's a German thing, to be honest, but people will also become quite protective of their data, I guess. Not only in the social media space, but data in general. And I think we really have to find a good common ground because it will be super beneficial to process the data, but maybe we don't have to share all data. So I think that's going to be, again, something that will have to be sorted in the minds of people. Like, what data shall we share and which one shall we keep for ourselves? And with that, I think we'll find a good compromise. And then things will happen that will be, out of our mind right now. Like, who would have thought that ChatGPT, something like those ChatGPT or other large language models was possible, let's say 10 or 20 years ago? Nobody would have had the idea, well, at least I didn't. And I think it's going to continue in that direction quite a bit. So like Casey said, software engineering will be so much more reliant on large language models or any coding AI. And it will change the way we operate and work in our day-to-day business. But it's going to be good. I'm pretty sure we'll get the problems and the things that are maybe scaring a few people. I believe we can get those sorted out, and then, we can make good use of AI.
Thank you so much for all the panelists, Matthias, Praveen, Mikhail, and Casey, for the insightful discussion. We can reserve maybe the next few minutes, Michael, for the audience questions.
Yes, we have
Does anyone
time for
have any
maybe
questions?
one question, and then we will move on to our next session. So please.
Awesome. Does anyone have any question before we move to the breakout rooms?
I need Michelle Pasili's contact information. So it's not a question, just a statement.
I'll reach out to you.
Thank you.
I was wondering if the AI can be used to help quicken the material qualification process. I've been hearing that it could take 2+ years to qualify a material for a battery manufacturer to accept a new material supplier.
That is a great question. It's not a use case that we've encountered so far. I cannot answer.
I think it's we've actually been playing with this in a couple different ways. So yeah, I mean, I think it depends on how we're doing it, but if we're looking at like predicting material properties, like that's something that for sure, I think we have some different use cases that we've been deploying. If we're looking at more on the LLM side, there's some work we actually are doing now that's on mining different test reports and pairing that with different publications to look for different patterns and analogs. So flagging different similar formulations or different failure modes to avoid either redundant testing or to shorten the qualification loop. And then I think there's also some random forest stuff where we might be looking at kind of predicting in advance whether a new material might pass downstream safety gates. So there's definitely a lot of use cases in this world.
Awesome. I think with that answer, that brings us to the end of the panel. Thank you so much, everyone, for the conversation. It was great. Thank you.
Everyone,
Thank
please
you,
give a
folks.
quick virtual round of applause for all our panelists and Aisa for moderating this panel. It was fantastic content and definitely learned a lot about AI here. Thank you.
Great.